again to this session of Steve, Stage Construction Modeling with OpenBridge Designer. Our presenter today is my friend, Steve Willoughby. So Steve, take it away, please. Start sharing your screen.
First thing we're going to do is jump in and review the plans for this particular structure. They were very preliminary. It was a structure that I modeled for a DOT early last year. I guess it was right pre-COVID. So we'll talk about the initial plans that I was given. There's 2 stages to it, and then we'll talk about modeling, or go through some videos on modeling the entire bridge. But before I even do that, I'm going to open up the model live and go over a few key concepts that really made this whole thing possible. And then after we model the whole bridge, then we'll come back and model it as a couple of different stages and review some of the functionality that we looked at there. So let's take a look at the drawings here real quick. So this is kind of the typical section that I was given. We have phase 2 over here on the right, and it is a given distance. It's 2 foot 8 inches off of a tangent to the survey line at a particular station. So what we have here is a 2-span precast girder bridge, going to be modeled and built in 2 different stages, and it's a straight bridge on a curved alignment. So a lot of different little things going on. We have some super elevation going on, some different girder spacings going on here. So we're going to take a look at how I went through the modeling process. And it wasn't perfect the first time, and I learned some things along the way, and part of that is what I want to share with you this morning. So go ahead and get out of that. And like I said, I'm going to go ahead and open up one of the bridge models here, and let's see. Yeah, we'll work off of this one. So what we're looking at here, this is OpenBridge Modeler here. So here's the original alignment that I was given, this state route here. And as you can see, it's a curved alignment, about a 1,300 foot radius here. And I was given that in an ALG file, if I remember correctly. So I just imported that into a 2D model and referenced it here to my 3D model. And then I first constructed this line right here. So in that same geometry file, I constructed that tangent, that local tangent, at the station we were given in the plans. And then relative to that line, I offset some other lines to represent the edge of deck, and then eventually the gutter line as well. So if I go into my levels here, and let's turn on those levels in view 1. So these white lines right here represent some geometry that I used to tell the software where precisely is this line right here, and then also where is the edge of deck, and more importantly, and I didn't really end up needing to use the edge of deck one, I ended up using this flow line here, and I'll explain why in a moment. So for this line right here, if I select it, you'll notice it's 2.667 feet off of that local tangent, which is that 2 foot 8 inches that I was given. And initially I started with just that little piece of line right there. Now you'll notice if I zoom out, there's actually 3 lines here. There's another extra line here and an extra line up here, and I'll get to that in a moment. But initially I started out with just the first piece there. And then once I knew that line, then I took that line and copied it parallel to represent my edge of deck on each side. So I knew, if we go back to that little drawing, I knew the distance from that line to the edge of deck on each side. So you can see those values shown here. And then I also knew, and I initially used that to model the edge of the bridge deck. And that worked fine for the edge of the bridge deck, but the way the flow line was defined, it still came in curved. It was still coming in parallel to my bridge alignment. So I had to create lines that represented the gutter line on each side, and they were just offset that 1 foot, I believe it was 8 1/4, off of the back edge here. So I think one of the other drawings shows that, yeah, 1 foot 8 1/4 typical width here. So I offset each of those lines as well. And then once I had those lines, then I could use those as my point controls for the rest of the structure. And now there was one trick here, and that really was this line right here. When I went to model the bridge, and I initially only had this single line right here, it was unable to model the deck as a solid. And I kept getting an error about some crossing lines, or I don't know, it just couldn't create that solid. So I reached out to the developers and the product manager, and we had a quick little call, and they explained to me that basically this line right here, and the bridge itself is heavily skewed. We didn't really mention that earlier, but the bridge is very heavily skewed here. When we model the deck, we actually model it longer than, let's say, the final deck that you see in the model. We model it a little longer, and then we clip it off at the support lines before we show you that final deck. So keep that in mind, because what happened is this line right here, on the extension of it, when it modeled the bridge deck on, let's say, out here in this region somewhere, this line actually crossed my center line. So what happened is that the basically one point on my deck template was going to end up crossing over another point. Basically, it was going to go from the right side of the deck template, or from the right side of one point to the left side of the point. So let me just show you, for example, on stage 2 or 3 here. So it was that this 0.7 was actually going to have to cross over the alignment, and that became a problem because our profile grade line was along that point. And oh by the way, the profile grade line was some vertical distance down below the top surface as well. So we kind of had that sort of thing going on as well. So a lot of just little things going on there. And then so here is my deck for stage 2, right? So here's my profile grade line. Here's the point that's 2 foot 8 inches over from this point, and then the rest of the deck template. And then now 0.1 here, all right, that's the one I'm going to eventually assign to this white line right here, all right? And what that will do is, since 0.2 right here, let's go look at how 0.2 is defined. So 0.2 has a horizontal vertical constraint on it, and it's relative to 0.1. So it's a fixed distance from 0.1 to 0.2. And what that does for us, so by me setting 0.1 and making it a tangent line, that forces the right edge of deck to be now parallel to this line. So I didn't really have to set both of these. I thought I was going to have to set both 0.1 and 2, but it turned out, by virtue of how I define my deck template, I really only had to define one of them to get this to work out well. And same sort of thing on the left side as well here. In this case, 0.3 will follow this line right here, and 0.2 in this case is a fixed distance from 0.3, both horizontally and vertically, and that will force the 0.2 to move quite nicely as well. So let's go take a look at the videos here. So we'll get out of there, jump back into here, and let's take a look at this first video. So I'm starting out with basically an empty file. I've referenced in the geometry file, and I've created my line work here for my point controls for the stage construction line and then the flow lines. So I'm going to come in here and just tell it I want to add a bridge to the model, and go out here and place my support lines out here. I know the station they begin at, and I know they're not actually at a skew angle per se. They're all parallel to each other, so I'd done a little math ahead of time and figured out what that angle was of that line. So you can see these are roughly a 35-degree skew. I believe that's what it was for the center one, and the other lines are simply parallel to it. So, and oh, by the way, we have two different span lengths here, so we have two different depths of beams. We have all kinds of fun stuff going on here. So anyway, so we'll go ahead and place these support lines out here, and then, of course, place the deck next. And I have my deck already selected here, so and that's the full width deck. So we're modeling the entire structure here. So I go ahead and just place it out there initially, and I didn't worry about telling it about adding constraints or point controls or any of that. So here's what the deck looks like initially, right? Everything's just parallel to that center line alignment. So I'm going to come back and select it and say, let's modify some point controls here. So I'm going to come in here to point 1, for example, and tell it I want to assign a horizontal point control to this. And so I just move out here and hit the select button, and I select that inside line. And when I hit apply, notice how it straightens that out very nicely for us. And then I'll do the same thing on the left side as well. So I'll come down here to point 11, tell it I want to assign a horizontal point control to that point as well. Select the line and apply it, and we won't be able to see it happen until we close this window, but that straightened out the left side as well, and this is precisely what we wanted that final deck to look like. And then everything from there is pretty straightforward as far as girder placement and substructure placement and so forth, especially when it's the entire structure here. So the beams were actually symmetrical here under the full width of the deck. So I just had to go in and made some assumptions on the support line offsets, got my beam layout defined there, and then I went in and placed those girders there. And this particular bridge used some pinned up beam sections here. So span 1 was this particular girder, and so I only wanted to apply this to all the beams on the first span. So I'm going to go in here and give it a minimal haunch and camber amount here, and then I'm going to go ahead and copy that to all the other girders in span 1. And then for span 2, do the same sort of thing. Come in here and pick a beam section, set my haunch value here, and then go into my start template, pick a beam section, and that was only a 33-inch bulb T, and then go ahead and copy that to all the other girders on span 2, select OK, and let it model those for us, and then we'll just rotate this around real quick just to show you we do have 2 different depths of girders here. And then place pier and so forth, all that's nothing really unique here. I did use some custom abutments here. These were actually some proof of concept functional components that we had created early on. So with these custom abutments here, this particular one, like I said, is a functional component. You can place it out here based on some original sets of variables that you have defined with that 3D parametric cell. And then once you place that out here, you could go out and select it afterwards and modify the variables associated with it and watch it react to that geometry. And it's something we've spent a lot of time, both Alex and I, over the last couple of years working with agencies on getting these 3D parametric cells created for their workspaces, because invariably a lot of agencies need these, depending on they may have some unique geometry that we can't handle with our basic tools, and so these functional components tend to work out pretty nicely. So go and place bearings and so forth, add barriers, nothing really unique there. So now let's jump in and take a look at modeling this same structure by stages. So we've got kind of a longer video here where I'm going to model both the left and right half of it here as two different stages. So I'm going to come in here, and again, starting out in a similar looking file, I tell it that I want to model a bridge called Stage 2. And a lot of the early stuff here is going to be pretty much identical. I'm going to place the very same support lines out here. Then I'm going to come out here and pick a bridge deck, but this time now I'm going to use that Stage 2 deck. That'll only be the right half of my structure. So once I place it out there, and I remember to snap to it, there we can see where we have the curved deck, excuse me, and then I can come back and add point controls for both edges of this. So I'm going to tell it for the gutter line here, I'm going to control that with that same horizontal line I used a moment ago. Select that point and accept it. And that straightens out the right side quite nicely for me. And now I need to straighten out this curved side, because this stage construction portion is a straight line here. So for 0.7 in this case, I need to go in and select a horizontal alignment for it as well. So I'm going to pick select, go out and select anywhere on that white, 3 sets of white lines. I combine those into a single, what's called a complex chain. Now, one thing, I'm going to pause this for just a moment. One thing to keep in mind is all these lines that I'm using here as point controls need to be civil geometry. Okay, you can't just use the generic microstation place line command and use that to control these points. They do have to be civil geometry that's created up here on the civil tab with the horizontal alignment tools. Okay, so just remember that they do have to be civil geometry for us to use those as point controls on here. So model the right half here. I'm going to go ahead and do the beam layout for this right side while we're here. So select my support lines and tell it that I want to do this beam layout. Now, this was the first version of the software, and this was about a year and a half ago. But this was the first version that allowed us to place a beam such that the entire top flange was not covered by the deck. So you'll notice this left edge distance here is a relatively small number. But it did give me what I needed there to be able to lay out these beams. And we'll see here in a moment that just a portion of that girder ends up being exposed here. So we'll go into the beam layout now, go in and select the different girders for each span, just like we did before, but now we have just these 3 beams here on span 1 and the same on span 2. So we'll copy that one for all the beams in span 1, and then I'll do the same process here for span 2 with that shorter girder. So we'll click on through this, go ahead and copy that to all the other beams out there, select OK and let it model them. And when it gets done, we'll be able to see that sure enough, it did allow us to have that beam flange partially exposed there. So again, this goes back about 3 versions or 4 versions of the software when this was first enabled. And then now what I'm going to do is I'm going to go ahead and model the left half of the structure as stage 3. So I went back to the Add Bridge button, and I'm telling it that I want to add a bridge to the model. So I've added a second bridge to my model. And then just repeat the steps from the first stage. So we'll go ahead and let this play out for just a moment. So we'll let it place those support lines out there. These are going to be, of course, precisely on top of the previous set. And then I'll pick the deck that I'm using for this stage. So I did create, like I said, 3 different deck templates here to really represent what we had going on. And again, initially looks a little odd, and you can, if you turn on add constraints initially, you can add those constraints from the beginning. You don't have to go back and do this as a second step. It was mainly just to demonstrate the effects of what was going on here, so everybody understood how those point controls were controlling what was going on the deck. But really, again, the really key thing is these point control lines that you draw, think of them as being infinite, right? If you remember back to your geometry class back in high school, lines were infinite. And so you have to make sure that these won't cross or force your section to somehow cross some other point, such that maybe 0.6 would end up to the left of 0.5 somehow. So that's why these are extended out and make this and help this work precisely how we want. Really nothing else new here from here on out. It's going to go ahead and place the beams out here for this stage 3 bridge, and then, or do the beam layout, I guess, for that stage 3 bridge, and it has a different left and right distances here. So we'll go ahead and set those in, and those were all things I was able to either get directly from or compute from the typical sections that I was given. So now we have our beam layout in there, and then placing the beams is pretty much identical to what we did just a moment ago. So I'm going to kind of skip through a lot of that. So that gives us kind of the final looking bridge there. Now at this point, and the one thing I didn't do in these particular videos is create, let's say, some piers and abutments that were only maybe for stage 2 and stage 3, but there's no reason you couldn't do that. The only trick there, honestly, would probably be just the understanding that in our abutment library and pier library, the key point on the top of those is at the center of the cap, transversely. So you'll probably need to use some kind of an offset here to get that pier to come in the right location. And when they're skewed, then that adds a little more math on your part to figure out that length, because you may know the distance radially, but it's actually that distance is along the skew line. So you'll have to take that angle into account, maybe do a little more math to figure out, you know, precisely how to get that pier abutment place there in your model. But it's not anything that any of us can't do, and it, you know, just takes a couple moments, and you can get that precisely where you need that in your model. So I know we're stopping a little bit short here, but that's a majority of what I wanted to show here this morning. I will go back to, and like I said, I do have these models open. Now you will notice one big difference between this model right here and what you saw a moment ago. When I had the model up here a moment ago, and again, this was from our version about 2 years ago, we didn't have materials defined in our library. So a lot of these things just had solid colors associated with them, similar to what you might see, oops, I can tile that, what you would see if you, did a transparent rendering, let's say, or something else. They just had regular colors assigned to them. They didn't have materials then. So when I was preparing for this presentation, and if you ever have an old file like that, let me show you one other trick that I just did earlier this week with this. When I initially opened this file, my deck was orange, my barriers were green, the beams were yellow or whatever color they were, and I didn't want that. I wanted the new materials assigned to it. Well, there's a very simple way to do that. It's not intuitively obvious, but it is right here in your Explorer window. So if you go to OpenBridge Standard, so this file again was created with like 10.08.00. and now I'm up on 10.9. I could have also done this with 10.10. But even in 10.9, what I did is I went into my standards here. I selected my current file. I right-clicked and said, update standards from DGNlib, because I knew the default DGN library that comes with OpenBridge now does have materials assigned to everything out here. And this could be our library. This could be some DOT library that you want to update your model to reflect. So that is probably not documented, but a really, really handy tool there to allow you to go in and update a much older model to your current standards. So if there were, let's say, feature changes to your levels for your features or anything else, or honestly, since from between 10.8 0 and 10.9, there's been a lot of changes in the feature library, and all of those were basically applied to this model just by doing that one update. So some of the new decorators and items like that came in as well. If I had piers and abutments in here and I was in 10.10, it would have gone ahead and drawn the outlines of the footings and some of the other 2D decorators that are present now that were not there before. So so anyway, that's my presentation on modeling a bridge in a couple of different stages. This may not be the only way. I'm sure some of you have done this as some other methodology, but this is certainly a way of doing it, and worked out pretty well on this particular project. So with that, I assume Alex has been answering questions. I've seen some things popping up randomly here or there. Are there any questions we need to address maybe live here, Alex? Or
Yeah, there is last one that Brad just placed it, that to add the ability to create a stage line after the bridge is created.
So we've been looking into that, Brad, and I probably need to reach out to Sri, our product manager, again. I know there was talk probably a year or two ago, I don't know if you remember, Alex, of there was going to be some new type of solids that our platform group or our MicroStation folks were working up, and were possibly going to give us the ability to go in and cut things, let's say, after the fact. But I haven't heard much more about them, and I haven't really asked about them lately, so I probably need to follow up with Sri, and then I can follow up with you as well. And I think they are looking at adding more in the future. I know we're starting to get requests from agencies to have maybe more specific tools up here, specific to stage construction, right? And we do have some basic things there now that mainly apply analytically for the OpenBridge product, because you'll notice if you look at any of the properties for any of the elements out here, they all have a build order. And primarily that's just used with our OpenBridge software now, but there isn't any reason that in the future that we couldn't use something like that, or maybe some other parameters.
We do that for we do that for segmental bridges, and we just send that on the build order for RM, but not on that pre-stress girders. Now the workaround kind of a workaround that Steve is proposing there, Steve this year, is just right. I mean, just maybe prepare the bridge to have control lines, and then when you move the control line, the bridge will move too. So
right, absolutely. Those white lines that I have out here for my alignment in that, like this line right here, I can change any of these values, and I really did it on purpose. I defined this one line, that one white line, off of and here, let's just go ahead and turn everything else off. So I defined my one piece of geometry there relative to my tangent line here. So this tangent line was, again, defined relative to my curve, and then all the other lines out here were defined relative to that. So I offset that to define that construction line for this inside edge, or along the center line here, and then the rest of these lines were defined relative to, actually this line was defined relative to this line. So let me
Now,
go in and turn that other one on.
As Noreen asking, how you add the civil lines there. So the civil line, you got to add it using the civil tab, right? So,
Right, so this,
these are the Y lines, Noreen, are that line.
yeah, these
A
horizontal
regular
lines.
microstation line, yeah.
Right, these
It's
horizontal.
not a microstation line. It has to be a civil line, right?
Right.
That's what we call a civil line. It's just adding the drafting is like adding a microstation line. What happens is we put properties there.
Right, you
So
can have some
that's
intelligence, right, where it would react if the alignment changes or something like that. But that's why I defined this line first, and then everything else relative to it. So if I move, if I change the offsets for this line, then all of these other lines are going to move with it. And there isn't anything, and I actually noticed some things I had wrong even in the template here, right before we started. So like on this particular deck template here, if I go look at its properties, I actually define one of the points wrong here, or actually a couple of them. But you can always go back to the library here and make changes to it. So this is my stage 2 deck. So just to kind of demonstrate this, let's rotate this around just a little bit so we can kind of see it happen here. But if I go into the stage 2 deck, there were actually 2 things I noticed I did a little bit wrong. Point 2 here, well, you'll notice actually point 3 is falling outside of point 2. So vertically, it should have lined up with point 2. So I defined it as a fixed distance off of here, which wasn't really correct. So really the more correct definition would just say a horizontal value from point 2 of 0, but elevation wise be the same as point 4. And so if I save that, that'll clean this up. And then point 2 was wrong only because when I went back and looked at the typical again, I have this vertically defined as being a 3-inch offset off of the flow line, but it was actually a 2-inch. Should have only been a 2-inch difference here. So I can go in and change that to 2 inches and save it, let it update the model here. And then when I close this out, that forces it to redraw the deck and the beams and the barrier, and since everything was all tied to that, updated all that quite nicely for us. So, but fortunately on the stage 3 one, I did get these points correct. So I do have too much of a, I still think I have the 3-inch vertical here, but it was defined correctly otherwise. So keep that in mind. You can always go back and change your deck template and have that update this here as well.
okay, good. Now there's a question here that if I want to analyze each state in LEAP, do I have to create 3 separate bridges to export, correct? Yeah, on that, yes, but you got to be careful because LEAP does not, doesn't do any kind of stage construction analysis. That will be RM, in which you can activate or deactivate elements. So in order for LEAP to design, it needs to be kind of a complete bridge, not halfway, that it could be on stage 1 or 2. So if you really want to do a stage construction analysis on each part, we will recommend to do it RM because it's designed for that. In LEAP, you're right.
Yeah,
I mean,
conversely, though, I think, I mean, they would,
bridges.
I think conversely, I mean, they would need to analyze this as its own, because there is going to be a time where this is by itself. So, if I came up here to Leap Concrete and said send to, it's going to send the active bridge and active unit. So how do we know what that is? So the one with the green icon here is the active, quote unquote, active bridge. And within each bridge, you could have multiple units, and one of those is always active as well. So to switch between bridges, one way to do it is you can right-click right in here and say make it the active bridge. So actually, this one's not active, so I can right-click on it and make this one the active bridge. But whichever one's active, that's what will be sent to the concrete. So yeah, you're probably gonna have to, if you do want to do that, yeah, you might need 3 separate bridge models today to do that.
Okay. But then again, these will not do any kind of time-dependent analysis.
No.
Sometimes it's intended for stage construction modeling.
Just
Right,
the more simplistic analysis you would get from LEAP, right? But yeah, it should go over fine either stage to LEAP.
I can see in the model, Steve, that is beyond the center line of the girder, or is along the center line of the girders, the middle of the joint. On the stage construction that you have is just
this line right here.
Can you turn off the second stage, please?
We'll turn off stage 2.
Stage 2.
Yep. Let me make the other one active here.
So sometimes it's easier to talk than it's to type, Steve. No, that is not it. The other one then.
Yeah. Well, they were in the chat, Steve. They were like saying that split line, right? That you're doing.
This one right here.
White line. Yeah, this has to be passing the center line of the girder or not, because they were having issues with that.
The girders can be like they are always straight, right?
Yes.
So if that because that is straight and the bridge is in a curve, then probably those girders are not a straight line. It's like one line segment, second line, third line. They repeated by the girder themselves, center line of the girders, right?
Well, so these beams are relative to my edge of deck, but since both edges of deck are straight, then the beams are straight. But even so, right, Raul? But by default, when we go to do our beam layout in here, if we're doing a precast girder bridge, the software automatically turns on chord, right? Whether we really need it or not, even if our alignment is tangent, it still turns on that chord option. So let me go down to my beam layout.
Yeah, because mostly because
it knows precast beams are straight, right? So
in this case, a long chord, but you can have short chords, you know, as a situation where if you want to go through LEAP, you mentioned, Alex, about the 3 models. Yeah, because you might want to analyze, but the interior girder is probably has more strength than the exterior. But however, you make the exterior with the same capacity as the interior girders. Of course, you want to check for maybe construction loads, maybe. But I just wondering if Steve Tizier was asking, or somebody was asking about if the deck can go to a line which is along the center line of the girders. Is that
or less than the center line of the girders? The deck line has to be passing or not? That was the question.
Yes, so
they were having issues. So
it can be 1 millimeter past the center line of the girder.
Could be.
Oh, okay. All right. So yeah. All right. Thanks. Very good.
Right.
Any other questions there?
There's a whole discussion on ProConcrete now.
ProConcrete? I love it.
So no. What's happening is ProConcrete is working on the ability to reinforce a functional component cell. Right. This is something that we're trying to do it as a functional component, and even store it on the library already reinforced. That is the final goal. But yeah, they are still working on that. Right. ProConcrete has the ability to reinforce a parametric cell as it is, parametric cell, but not yet, as I heard, a functional component or even save it in our library as such. That is the final goal, and we're still working on that.
I believe
it's something that is long awaited.
Yeah, their goal is for the next version of ProConcrete to have that. So next major version. So
exactly, it escapes kind of our controlling bridge, but then we're pushing on that as well as you guys. So
we still can use ProConcrete though to do certain type of piers because of the dynamic functionality that the rewire will follow the new modifications of this particular pier. Then we can do that, right, for drawing production and list calculation and weights, right? Yeah.
Yep.
So it's not impossible. It takes a little bit of time, but the production results is amazing, right?
All right. So, okay. So that's all there is, guys.